In a world ruled by steam, one engineer dared to imagine the future. If you are drawn to the stories of forgotten innovations and lost engineering revolutions, subscribe now and join us as we uncover history's bold experiments. By the 1890s, steam locomotives had become the backbone of transportation, powering trains across continents and threading cities together. Their iron wheels and pistons drove the industrial age forward, but beneath the thunder and steam, a stubborn problem lurked. Hammer blow, the relentless pounding inflicted by steam engines' driving wheels, sent shockwaves through the rails with every revolution. Each piston stroke delivered not just forward motion, but a jolt that battered the track, shaking carriages and passengers alike. This was not a minor annoyance. Hammer blow cracked rails, forced expensive repairs, and set limits on speed and comfort. The more powerful the locomotive, the greater the force. At high speeds, these vertical blows could warp rails and even threaten derailment. Railway engineers struggled to balance raw power with the need for smoother, safer rides. Innovations in wheel balancing and track design helped, but the fundamental flaw remained. The direct mechanical connection between the engine's pistons and the driving wheels made true high-speed stability almost impossible. As steam ruled the rails from London to Moscow, the world's railways faced a dilemma. The promise of faster, more reliable trains was held back by the very mechanism that made them run. The industry's brightest minds searched for alternatives, solutions that could deliver power without the destructive side effects. In this world of smoke and steel, the hammer blow problem was more than an engineering quirk. It was a barrier to progress, and it demanded a new way of thinking. If stories of lost inventions and engineering revolutions capture your imagination, subscribe and join the journey into history's boldest experiments. Jean-Jacques Heilmann was not content to accept the limits of steam. Born in Mulhouse, Alsace, and raised in a family of inventors, he carried a restless energy into the world of late 19th century engineering. In 1890, Heilmann founded the Société Industrielle de Moteurs Électriques et à Vapeur, setting out to tackle the most stubborn flaw in high-speed rail, the hammer blow that shook tracks and threatened progress. Heilmann's answer was nothing short of radical. Instead of letting pistons drive the wheels directly, he imagined a locomotive where steam would power a generator, and that generator would feed electricity to motors on each axle. This steam-electric drivetrain, almost unthinkable in its day, promised to break the cycle of pounding and vibration that plagued conventional engines. By decoupling the mechanical link between engine and wheels, Heilmann aimed for a smoother ride, more stable at speed, and gentler on the rails. The design called for a triple-expansion steam engine, an advanced system that squeezed every last drop of energy from steam, connected to a powerful direct current generator. Electricity from this generator would flow to multiple traction motors, each mounted directly on an axle. The result, torque delivered evenly across every wheel, adhesion improved, and the rough, unpredictable surges of piston-driven power replaced by a steady, controlled pull. Heilmann's firm began to take shape around this vision, assembling a team to turn theory into reality. The promise was clear: smoother, high-speed running, less coal burned, and a future where the old boundaries of steam could be redrawn. For those drawn to forgotten revolutions and the boldest experiments in engineering, subscribe and join the journey into history's untold innovations. In 1993, the Fusée Électrique challenged every convention of locomotive design. Its cab-forward silhouette, with the crew compartment leading and the smokestack trailing at the rear, was a direct response to the limitations of traditional steam engines. This arrangement placed the operators ahead of the heat and vibration, offering a clear view of the track and a radically different working environment. Beneath the streamlined exterior, the Fusée Électrique's layout was a study in purposeful engineering. A two-cylinder compound steam engine, developed with Swiss expertise, sat transversely just behind the cab. Steam first entered a high-pressure cylinder, then expanded into a larger low-pressure cylinder, extracting as much energy as possible before being exhausted. This triple expansion process marked a significant step forward in efficiency, squeezing more work from every pound of steam. Instead of sending power straight to the wheels, the engine turned a massive direct current generator rated at 360 kilowatts and built by Brown, Boveri, and Sailly. Spinning at a steady 300 to 400 revolutions per minute, the generator supplied electricity to 8 traction motors, one for each axle, arranged in 2 4-axle bogies. At low speeds, the motors were wired in 2 groups of 4, delivering smooth torque and steady starts. As speed increased, the motors switched to parallel operation, distributing power evenly along the chassis. This setup delivered a level of adhesion and stability that conventional steam locomotives, with their pounding pistons and uneven wheel loads, could not approach. Supporting the main powertrain was a network of auxiliary systems. A compact vertical steam engine producing 13 horsepower drove a secondary dynamo. This auxiliary generator powered the lighting in passenger carriages and energized the air brakes, a significant advance at a time when most trains still relied on manual brakes. For stopping, disc brakes were fitted to every wheel, a rare feature that signaled a new standard for safety and control at high speeds. The interior was densely packed with machinery, wiring, and controls. Crew members navigated tight quarters, separated by the bulk of the generator and a maze of electrical connections. Maintenance demanded specialized skill, and the sheer complexity foreshadowed future challenges. Yet every element of the Fusée Électrique's architecture spoke to a vision of high-speed rail decades ahead of its time, a mechanical manifesto built to solve the old problems of steam and point toward new possibilities. On a gray morning in 1894, the Fusée Électrique rolled out onto the Paris to Le Havre main line, its cab-forward shape slicing through the mist. The trial route was no gentle proving ground. For 10 kilometers, the track climbed a 1 in 125 gradient, a stretch that tested even the best conventional locomotives. But this was not a conventional machine. Steam surged into the compound cylinders, spinning the Brown Boveri generator at a steady 400 revolutions per minute. Electricity flowed to 8 traction motors, each axle pulling its weight with silent determination. The train gathered speed, climbing the grade with a smoothness that defied expectation. Official timing posts ticked by, first 51.5 kilometers per hour, then 59.4, then 70 on level ground. Observers lining the embankments watched in disbelief. There was no hammering, no jolting, just a steady surge. Torque delivered evenly. The rails spared the pounding that had haunted steam locomotives for decades. One railway inspector, not known for hyperbole, remarked that the ride was as smooth as a Pullman carriage. For passengers used to the clatter and sway of ordinary express trains, the difference was unmistakable. As the Fusée Électrique crested the gradient, the numbers kept climbing. On a straightaway, the locomotive reached 107 kilometers per hour, a speed that placed it among the fastest rail vehicles of its era. The achievement was not a fluke. Over the course of 2,000 kilometers of test runs, the prototype delivered consistent results: strong adhesion on steep grades, high speeds on the flat, and a ride quality more akin to luxury than brute force. Coal consumption told its own story. Careful measurement showed a 15% saving compared to similar steam engines. Every ton of coal burned in Heilmann's design carried the train farther, the triple expansion engine and electric transmission squeezing more work from every shovelful. In an age when fuel costs shaped fortunes, this was more than a technical curiosity. It was a promise of efficiency. The press took notice. Headlines marveled at the absence of hammer blow, the new standard of comfort, the audacity of a French engineer who dared to rethink the very nature of rail travel. Engineers from across Europe arrived to study the locomotive, pacing the platform, notebooks in hand, searching for the secret behind its performance. In the cab, the reality was more complex. The crew worked in close quarters, separated by the bulk of the generator and a tangle of wiring. Driving the Fusée Électrique required not just a fireman and an engineer, but an electrician as well, a sign of the machine's sophistication and its challenge. Yet for a moment, as the locomotive thundered past the speed posts, the vision held. The old limits of steam seemed to fall away, replaced by a new kind of power, smooth, quiet, and controlled. For those who find inspiration in the forgotten triumphs of engineering, subscribe and join the journey into history's boldest experiments. Even today, many innovations fail not for lack of brilliance, but for arriving before their time. As railways now revisit hybrid and electric propulsion, Heilmann's vision stands as a reminder: history does not always reward the first to see the future. Subscribe for more journeys into engineering's forgotten revolutions.